All right, hey everyone, thanks so much for joining. My name is John Hyman. I'm one of the co-founders and the CTO of Braze. I'm here today to talk to you about how we use AWS services to help us auto-scale and send over 1 billion messages every single day. But I do want to give you some context on what I mean when I talk about messages. So I'll first start just giving you some background and perspective on the scope of our business, the scale of what we operate on, and the types of data we process, and what I mean by messaging. So Braze is a customer engagement platform. Our goal and mission is to help consumer brands use data to personalize and deliver great customer experiences through messaging. These are things like sending personalized emails, personalized push notifications, in-app messages, web messages, and more. And when I talk about delivering great customer experiences, what's important in that is the focus on essentially time. And we think about things in terms of being real time or not. But real time is essentially, I think, a term that's a bit overused. So I try to have our customers focus on the thoughts of two different things. One, the value of time when it comes to the data that they generate and its usefulness. If you're developing an email strategy or a push notification or engagement strategy, it's simply better to use more recent information to personalize your messaging than stale or older information to deliver a good strategy. And then second, thinking about if you can effectively get insights from your data as fast as possible, because again, the value of data is going to deteriorate as soon as you collect it and as soon as it happens, and you want to make sure you're primed to act on it in real time. So that's what we do at Braze. We work with a tremendous number of different customers. Chances are we're probably already in your pocket. If you've ever gotten money from a friend on Venmo and withdrawn it and seen it in that message to get it put on a Venmo debit card, then you've seen a Braze in that message. Or we've gotten a push notification from Domino's Pizza letting you know your order's on the way, and that was sent to you from Braze. Across our customer base, we engage more than 1.6 billion monthly active users, and we send over 1 billion of these messages every day. That's essentially like 1 million messages every minute, 24 hours a day, 7 days a week, nonstop. So this is a good amount of scale, and I really want to talk about how we use AWS and the cloud to enable us to continue to do this in a great cost-effective way. So I want to start with two main problems in essentially our problem space. And the first is data processing. So we ingest data from a number of different sources. The way that our product works is our customers download Braze's SDK, and they put it into their mobile applications or on their website. So every time someone opens an app that has one of our SDKs installed, or visits a website that has our JavaScript SDK installed, then we're receiving information from that device or web browser about actions that that consumer is taking. At the same time, we work with a number of other different partners to ingest other parts of first-party data. So customer data platforms like Segment or mParticle ingest data into Braze. Attribution providers like AppsFlyer and Tune send data into Braze so we can have an understanding of where consumers were acquired from, whether it be Facebook or Google or anything else like that. And then our customers are also sending us data from their own backends. So all in all, we're processing millions of API calls every single minute. And when we get this data, we actually need to process it very, very fast. It's different than an analytical kind of use case where you might just be looking at graphs. For Braze, every piece of data that comes in could either trigger a new message to be sent or could cancel a message to be sent. Like let's imagine that you have a service and you want to send users emails when they register. So on an account creation event, send a user a new welcome email. That could be defined in Braze as a type of campaign. So we want to make sure that when we receive that account creation event, we're sending that message as fast as possible to provide you with a good customer experience. At the same time, data could stop a message from going out. A very common use case our customers send is something called a cart abandonment strategy. This is where you add items to a shopping cart, don't check out, and then you want to then send someone a reminder that things are still in their shopping cart. And I don't know about you, but I've also sometimes received messages to remind me to buy things that I've already purchased. Like I booked a hotel room, and then they're saying, hey, there's still deals for going to San Francisco on our site. That type of thing happens from using old data or not acting fast enough. And at Braze, we want to make sure we don't deliver a bad customer experience by making sure we don't send messages you shouldn't get because you've taken other piece of action. And finally, data that comes in can also provide us with great analytic information on the value and success of our customers' campaigns, whether or not a customer has achieved the goal that they were set out to do. For example, if you have a push notification aimed to drive in-app purchasing, we can make sure that when data comes in, we're seeing how effective that campaign is. So besides data processing, Message sending is another extremely important part of what we do. And our customers can send messages through a myriad of different ways. They could do a blast type of message, where they come in and just compose a campaign and send it right away. You can imagine doing breaking news this way, where just something happens, you want to send it to everyone as fast as possible. You could have scheduled messages. Maybe you have a weekly newsletter that goes out every Friday at 12 p.m. You could have these action-based messages that happen based on users triggering. You could have other messages that are triggered via our APIs. We get lots of different ways in which consumers can send messages. We also have our more sophisticated customers creating multi-day, multi-step, multi-channel messages with our Canvas product that I have a screenshot of here. It's kind of like a workflow tool where you can compose these multi-step strategies. But importantly, customers want us to send messages as fast as possible. Like if you've got a breaking news alert, you just want that out ASAP. If you've got a newsletter about sales and new products that you want to send your consumers, you want that out as fast as possible. Consumers aren't going to ever want us to slow down. The expectations are just going to keep rising on how fast we have to send things. So the challenge for us is, as a maturing business, how do we ensure that we can meet our customers' expectations and scale and send at the volumes they need us to send from, but without breaking the bank? Because you can always throw money at a problem and just add a lot more servers, but we're building a business here, and we need to make sure that we can do it in a cost-effective way for Braze, as well as for our customers. So I want to start talking about how we do this by focusing on the lowest level here, which is our database. We use a number of different database technologies. I'm going to talk about two here. One is Redis, one is MongoDB. We also use Postgres on Amazon RDS. We work with Snowflake as part of our data warehouse. But our main database that powers a lot of what we have at Braze is MongoDB. And we've developed a deployment model to allow us to put customers on different types of MongoDB infrastructure and configurations. So we have multiple different clusters of MongoDB. And what I mean by a cluster is essentially an installation of MongoDB that has shards, has load balancers, has a certain set of CPU, RAM, and disk requirements. And we actually have dozens of these different clusters. And when a customer signs up with Braze, we can put them on a shared cluster. This is essentially probably something that many of you have in your applications, which would be like one database, and in each table there's a customer ID column, and then you just have data for customers A, B, and C all in that same database table. But we do that for our smaller customers, and as they get larger, we then can start to split them out and give them more dedicated resourcing. So customers that are a little bit larger, that might be like Lyft or Venmo or Domino's Pizza, might be on a shared cluster where there are other customers on it, but they then have different logically separate databases. And this is going to allow us to scale them separately. And then if they're even larger, say like Yelp, we can put them on their entirely dedicated database. So 100% of the RAM, 100% of the disk, and the CPU, all going to be for them. And what's important and valuable is we can move customers across these tiers with minimal downtime and efforts. And it also provides us with good isolation from a security perspective. So once we have these different databases, we assign different port numbers to them. And then we build up our message sending capabilities and our data processing servers to be focused around these database clusters. So essentially, each database has a port, and then around that port, we're going to put message sending servers and data processing servers, and they're going to each then be able to do work for those customers there. So if you're Yelp and you have a dedicated database with Braze, you also have dedicated EC2 servers to send your messages and dedicated EC2 servers to process data from your mobile app, from your website, or that's coming in from attribution providers or other partners there. The way this is literally implemented as well is we have a big job queuing system at Braze. We process billions of jobs a day, and we use Redis to back all of our database queues. And we create different queues per database port. And then these workers will consume the queues that are on the same port locality that they're attached to. This provides us with really good amounts of isolation, because what this means is if a customer is essentially having an issue, or their database is perhaps having a problem, or we need to upgrade it, or there's just something going on there, we can keep a consistent quality of service for all of our other customers because they're not affected. They're on a different database, different servers are sending their messages, different workers are sending their and processing their data. So it provides us with really good guarantees there. And importantly, it also allows us to scale up these servers as needed and make sure that we're best right-sizing our customers as much as they need to. So a way that we do that is we then collect a lot of metrics. So I've just highlighted a couple of metrics here. We actually have dozens of different types of metrics. But we want to make sure we have a strong understanding of what's going on in our queues. So here are 3 sample graphs, the first being the amount of jobs that we have on a queue per availability zone. At Braze, we host with 3 different availability zones in each of our regions so that we have high availability. And we can then track how many jobs are in queued per zone. We then also are then breaking down what those queues look like, so we can see how many messages are, how many jobs are for message sending, or how many jobs are for data processing. And we can further break that down by port, so we can understand how many jobs do we have outstanding for Yelp versus Domino's Pizza versus Lyft, etc. And then we also can keep track of the jobs that are going to be scheduled in the future. So all of our customers that may have messages that are going out today at 5 p.m., we have visibility into what that's going to look like. And we look at it on a 5-minute, 15-minute, 30-minute, all the way up to 24-hour basis so we can see what's coming in the future from there. The next step is then we use AWS Autoscaling to create autoscale groups for each of these different configurations. So what I have here are 2 different types of autoscale groups. One is going to be around data processing, and one is going to be around message sending. But there are 6 on the screen because we do 1 per availability zone. So if you just kind of look and read what this actually says, I've got, say, a data processing group for port 11374, whichever customers those belong to, and I'm in US East 1A or 1D or 1C. And we control all of this with Terraform, which makes it extremely easy for us to manage this. As new customers come on, we can simply add lines of configuration to Terraform, Atlantis apply it, and just get these autoscale groups just essentially via configuration and GitOps, which is really exciting. But one thing to kind of call out is if you look at the screenshot here, you'll see that 2 of these autoscale groups have more instances than are desired. So for folks who aren't familiar with AWS Autoscale Groups, they're a really fantastic piece of technology that allows you to define essentially an easy way to scale up or down different types of servers. You can attach an autoscale group to a certain lifecycle script, and then if you say, I need 10 of these, AWS will bring up 10. If you then change your mind and say, actually, I want 7, they'll scale down 3. They'll manage that lifecycle for you. But it's hard for us to manage this lifecycle manually across the hundreds and hundreds of autoscale groups that we have across our customers. So what we've done is we've created an AWS Lambda Script that every 2 minutes is going to read a lot of different metrics. So the first thing we're going to do is query Fastly, which is our API ingress edge. We're going to understand how many API calls are coming in to Braze. This helps us approximate like how much data are we getting from devices and websites and our partners. We're then going to look at how many jobs are still in queue, as well as how many jobs we believe we're going to do in the near future based on some predictions we're making around message sending and load and other things like that. And then we do some math, because we can understand that a given EC2 server of a certain size can handle X jobs per second, figure out then how many servers we want on a desired basis per port, and then update it in AWS Autoscale. So what this means is this Lambda script essentially is controlling new server additions and removals all throughout the day. On a weekly basis, we add and remove over 10,000 EC2 servers, just constantly throughout the day. Every 2 minutes, things are coming up or coming down. What this graph is here is a list of different processes that are online to handle data processing and message sending. And you can see it's just in constant motion throughout the day. And there are also spikiness to it that may tend to align with things like 9 a.m., 10 a.m., 5 p.m., very common windows for customers to send messages to their consumers. But what's even better about this is we don't have to touch it. It essentially just works by itself. Our customers' messages go out extremely quickly, and we then ensure that when messages aren't sending, we're not paying for servers. So this helps us save a ton of money because we're just consistently and constantly right-sizing every single customer on an as-needed basis, as granular as we possibly can. So I talked about a lot of different things here. We do have a lot more information on this queue design of different customer isolations and how we've actually implemented it here. I'm going to leave up this slide for about 30 seconds or so, let folks write down the URL or take a picture. But we have a really great blog post that I'm sure all of you will really enjoy. It's a good complement to this discussion on how building a multi-tenant application and using job queuing and different database clusters for those different tenants really provides us with great reliability, isolation, speed, and consistency of our quality of service. So with that, I believe I have a couple of minutes of Q&A left. I think I've got about 6 or 7, so kind of turn it over to you. Thanks.
Yeah, let's give it up for John. Great talk. If anybody has any questions, just raise your hand. I'll run over to the mic. Or, okay.
I was just wondering, ballpark, what's your cost per month? How many servers are you using per month? You don't have to give me exact figures, but just to serve that scale.
Yeah, so Braze spends 7+ figures a year on AWS, and so essentially, like, there's a good amount of it that goes into this. The bulk of all of our costs on AWS do come from EC2, just because we care so much about having good quality of service. Like, it's important to us to send messages as fast as possible, not only because our customers demand it, but because we have the ability to actually hurt brands' reputations if we don't. If you order pizza from Domino's Pizza, and you get that push notification that your order's on the way, but it doesn't come for 45 minutes, you're going to blame Domino's, and you're like hungry and you're grumpy, when it could actually be our issue if we're not sending fast enough. So we want to make sure that we're just sending as much as we can, but that's where costs are a big deal for us, because we can't break our own bank.
All right, we have a question in the back here.
You mentioned you're using Terraform to do the deployments. Have you seen any issues managing that scale? How are you doing state files, things like that, just to make sure it's easily trackable and visible what's going on?
So it's actually a little bit hard for me to understand, so I'm going to repeat the question and let me know if I got it right. You said when we're using Terraform, have we seen any issues with config tracking and state?
Yeah, and just scale, tracking state files, all that kind of stuff.
So we have seen issues where people have then made manual changes, but our workflow for Terraform that we implemented about 8 or 9 months ago has been really, really fantastic for us as we've grown the team. So I've had nothing but positive experiences with it. It just gets a little tricky when people do things manually, because then we end up with an Atlantis plan that wipes away a lot of things, and then we've got to make sure that we don't undo a bunch of work.
Any other questions?
How many days or hours or minutes of data you keep in your database?
So with respect to data retention, our customers have different data retention policies that they may want to set with us for things like GDPR. But by and large, a lot of the data that we will have is going to be retained through the lifetime of that customer working with Braze. So for example, let's say you sign up for one of our customer services. They send you an email about it, like a welcome email. If you're still a customer with them 2 years from now and they're still a customer with us, we still know that we sent that email to you unless they've instructed us to remove that data, part of their retention policies. Of course, then with our customers, once they stop being customers of ours, we delete all of that data, but we allow our customers the ability to set those policies. But for much of it, it's in their benefit to have a history with you, at least of the messages they've sent you. The data and the events you've sent them, sometimes our customers like to age that out.